So thank you, Patrick, for the invitation, and thank you for the opportunity. Here with me are Ene and Anastassia. They are my PhD students here, and we are all working on bicycle network research, on quantitative bicycle network research. And we are happy now to present you some of our ongoing research and also to criticize our own research a little bit in the end. So as you just mentioned, we are NERDS. So NERD stands for Networks, Data, and Society. So that's the research group we founded a few years ago here. And we are around 15 people and growing. And what unites us is the love of networks of any kind. And here circled are we three, and we are basically the core bicycle network or sustainable mobility group. Yeah, so let's jump right in with some of the motivation why we are doing the research. So our main motivation is something like this curve. It's the CO2 emissions, the yearly CO2 emissions, where you can see that they are basically soaring upwards since the 1950s. And now we are at the point where if you look at the blue curve, that curve would be needed for us to implement to reach the Paris Agreement with 50% probability. So basically, we need a radical turnaround in how we are doing things on the planet, and the business as usual will just not cut it. And maybe let's start a little bit with this narrative that is being pushed a lot, that we could just replace all fossil fueled cars with electric cars. And yeah, unfortunately, that's not the golden goose as it is being sold. So that can help for sure with cutting CO2 emissions, but there are many issues with just following this approach. And I'm citing two papers that are very nice overviews of all the issues that you have with this approach of just focusing on e-cars. So the main problem is space, namely that cars, whether they are e-cars or fossil fuel cars, they just take too much space in cities. And the scarcest resource in city is space. So we need to switch to modes of transport that are just more space efficient. And because of these big disproportionate space requirements of cars, if you look at mobility space distributions in cities like here in Copenhagen, then most of the space is in red, and that's space allocated to cars, while one of the smallest amounts of space is for bicycles. But in Copenhagen, you know that most people commute by bicycle and only 9% commute by car. So there's a huge imbalance in how we allocate space and how we use it. And then another big problem, apart from that, is people dying in crashes. So 1.3 million people die every year from crashes. And again, if you replace fossil fueled cars with e-cars, the problem is e-cars are even bigger and heavier and accelerate faster. So these numbers will probably not go down if you just do that. So basically, thumbs up for electric vehicles eliminating tailpipe emissions, but huge thumbs down for all the other things that are problematic with cars and that will stay problematic with e-cars. So basically, we need to find better solutions, or we need to prioritize other solutions that are cheaper and more effective. And the main message that is that tech alone won't save us. So in all of these tech-inspired renderings, you don't see a lot of people on the street, because in this kind of vision, the space between your origin and your destination is the space that is not worth anything. You just want to overcome it as fast as possible. So that's this idea of having as fast as possible flow. while there are other visions where you give value to the public space and you try to make cities better. So these other kinds of visions, they look like this. Most of the noise pollution comes from vehicular traffic in cities, and most of the hazard. So if you remove that, you can make cities better. And yeah, I mean, there are many real-life examples where cities have implemented this kind of vision, and before the city tries to implement it, there is a lot of people who are against it, like 60%. But after it has been implemented, maybe 5% want to go back. So basically nobody wants to go back. And these measures improve the quality of life in cities. And what is being done here is that the big hazard to people is being eliminated or substituted by better solutions. And so there is this hierarchy of controls, which comes from workplace safety, where the idea is that, okay, you have factories and you have big machines that are killing your workers somehow. And what should you do to increase the safety? And so the most effective way is just to eliminate the hazard. But if you cannot do that, then you should substitute the hazard or isolate people from the hazard and so on. And the last step is to put helmets on the people. And so in this vision, you would basically try to eliminate the hazard or substitute it for time-tested technologies. And one of these time-tested technologies is cycling. It's also a technology that delivers on many sustainable development goals. And yeah, it's also an economic no-brainer to invest into cycling and walking in cities, because if you do the cost-benefit analysis, then you can show that each kilometer traveled by a car is a net burden to society, while each kilometer traveled by bicycle or by walking is a positive net benefit to society. So this is just some of the motivation for what we're doing. And so it's pretty clear that more active travel is crucial to make cities better. And then the question is, how do we actually want to build bicycle infrastructure? And here we have great planning guidelines from the Netherlands, from North America, that tell you about the decades of experiences of planners. But all of these guys, they focus mostly on kind of the microscopic view. So they focus mostly on intersection design, on street design, but they don't focus so much on the systemic view of the whole system. And that's where network scientists and our team comes in, where we want to really look at this kind of systemic view, at the whole network or the whole city. And so just as a disclaimer, because there is a geographic data science audience here, we use and we focus mostly on just structural network data. So data on the infrastructure networks from OpenStreetMap mostly. And we don't focus that much on empirical flow data like OD matrices and GPS data. Maybe we will focus on it a bit more in the future, but the first step for us is really to understand the structure, which hasn't been done yet. So we care first about the structure of cities, and we care also about accessibility for all. And focusing too much on flow data is problematic because flow data, for example, of cyclists, is mostly a reflection of the already existing built infrastructure, which can be very bad. So it doesn't make a lot of sense to trying to predict from the past flows, the future flows, but really you should proactively build a good city for everyone. So that's the idea, and that's also explained in big detail in this OECD document, by the way, Transport Strategies for Net Zero Systems by Design. Okay, so We had some finished research, which are 3 main papers on how you could build bicycle infrastructure. And I don't want to talk about this. We don't want to cover this. We covered it earlier, for example, in a YouTube talk that you can watch later. But now we actually want to cover our ongoing research. And I give now the microphone to Anastassia, who will talk about 2 projects, and then Anna will talk about another project.
Yes, so I hope you can hear me well. Apologies for my voice, I'm still recovering from a bad cold. But we wanted to bring also 2 specific examples of how we look at bicycle infrastructure and what we mean by having a network perspective. So one of the examples is going to be about urban cycling, so cycling in the city, and the second one about cycling in the countryside. And to start with cities. So what we have seen in the past years, especially that many cities have very ambitious bicycle network development plans. And we have some examples here from Berlin, Sofia, Milano, Vienna, and then also I found an example from Liverpool. When I've been to Liverpool, most of the people told me that the cycling infrastructure is not that great. So I don't know how ambitious you would find this plan. Maybe we can talk about this later, but just to give some examples. So cities want to do that, which is of course great. But often what is missing is a strategy to construction order. So how do we get from the network that we already have to this future network? In what order? And often this how do we get to the question is answered basically by we will get there randomly. So for example, and what we heard from our colleagues in Oslo is that there every time that some construction work on the pipes has to be done, people say, well, since we're already digging up the streets, let's also place some new bicycle infrastructure there, which can be classified as random development. And as some of Michael Spreber's research has also shown, this is not the most effective, as you can think. So what would be more effective is to consider the network structure as you build up. And our aim here is to find some computational method that can inform bicycle planners or urban planners about in which order to build up the network, so that at every step of the building up of the network, it is functional in the best way possible for the cyclists. And of course, what does it mean to be functional in the best way possible? That's still up to discussion, definition as well, especially when you have to put it into numbers. But maybe to give some example of what this could look like. What we have here is a toy network. So this is in reality is just an extraction from the network of Copenhagen. But let's imagine, so this is for the sake of having an example, that we have in the middle the red network links that are already built. So let's say that's the network that's already there. And then in this example, the blue lines, that's the development plan. So that's what should be added. And then you can ask, well, how do we do this? And what do we want to optimize as we build up the network? And here, for example, you can follow the strategy of optimizing directness. So trying for every path on the network to be as close as possible to the path as the crow flies as you build up. Or you can optimize for coverage, which would be trying to make the network cover the biggest area of the city as fast as possible. And you can then compare these 2 strategies. I won't go too much into detail here, but just to give you an impression of what it is that we're trying to do computationally. So we have these 2 strategies. On the top row, that's the directness optimization. And the bottom row, that's the coverage optimization. And then you see in the columns, so first 25% of the length of the new network built, then 50, and then 75%. And it's not that obvious from just looking at the pictures what the difference is. So of course you need some metrics to compare. But if you, for example, look at the column in the middle, so 50% of the length built, you can actually see that for the upper row, that's optimizing for directness. There's all these long paths already in the network, so the main streets, so to speak. And if you compare that with the bottom image where we're optimizing for coverage, you don't get as long as, so the main roads are shorter, but you get all these side roads also built as well at that stage. So yes, that's the basic idea. It's a bit tricky. I have a backup slide here, which I'm going to jump over, but we might talk about it afterwards if you have more questions about the metrics and how we compare them and compute them. But to get back to the trickiness, maybe, there are quite a lot of challenges on our way to really formulating something computational like this with real life data. The first big challenge being the data, as you might have guessed. So even if bicycle network plans are available online, it's often not that easy to then actually get the geodata underlying them. And then even once you get the data, it's not said that we can also match it to the street network, and it's not said that we know about population densities and all of this other data that might be relevant as well. And then also you have to challenge that what is even defined as bicycle network that varies from city to city and from country to country. So in Vienna, for example, in my hometown, this development plan that we found, it's about opening streets up for bicycles, but without removing the cars, so creating so-called bicycle streets, which from our perspective, we always talk about separated infrastructure. So that would not be part of the bicycle network for us, but then in Vienna, it's part of the bicycle development plan. So it's also a question how to deal with that. And then another big challenge, which if we have time, I would love also to hear whether some of you encountered it or maybe already have a way of dealing with it, is that many of the networks, and I put it into quotation marks here, that we actually do get from cities, they are hand-drawn in a way. So it's basically a bunch of line strings that to go from there to actually the network that we work with, which is a mathematical object and the graph. It's unfortunately not a straightforward process and quite time consuming. So we're trying to work with that right now. So that would be it for the urban cycling. And then the other project that I wanted to briefly present here is about cycling node networks. And cycling node networks, I don't know if some of you have maybe heard the concept. So this has been popularized in Belgium, the Netherlands, France, Germany also. This is basically the idea that people can cycle and do round trips guided by a series of cycle nodes that have signage posts. So what you see on the image here, it's Bornholm, that's a Danish island. And you see the green links, those are parts of the cycle node network. And then the green dots, those are the nodes. And how this plays out in real life is that at each dot, so at each node, you basically have a signage post. At each node, you have a signage post that directs you to the next node in the network. And it's especially thought for people who want to spend a day trip, do a round trip, and so on. So more directed towards rural cycling. And so that's for tourism and for rural cycling. It has been tested, and it's a great idea. But it's still unclear how to actually plan a network like this. So the way it's done now, it's mostly manually with the local knowledge of the people who are planning in that region. But our ambition is to contribute to a computational scaling up of how to plan such a network, for which we need, on the one hand, the local characteristics, of course. So imagine you look at an island like this, you look at the map, you know where the streets are, where cyclists could possibly be. So what would you want to know? So probably you would want to include all the points of interest for tourism. You want maybe routes that have facilities on the way, like public bathrooms, for example. But also you would like to know how nice or how beautiful is each of the stretches, and should I go here or should I go there? Maybe it's the same length, but maybe one of the stretches is just from the landscape much nicer than the other. So you need to, somehow get the data on all that. But then on the other hand, what you also need to consider are more the structural network properties that underlie such a network. And there you can, and this is what we're trying to do now, come up with numerical formulated constraints that you impose on such a network. For example, you might want to say, well, if we have more than 100 nodes in this network, more than 100 signage posts, then we will not be able to maintain it. So yes, you can put an upper limit on the number of nodes. Or, for example, you might want to say we want to have a node at least every 5 kilometers, because otherwise the cyclists might get bored or distracted, or they will not know whether they're still on the right way. So the node density could also be a constraint that you impose structurally. And we're trying to, we're working together with several stakeholders in Denmark who have the ambition of rolling out such a cycle node network for the whole of Denmark. And our contribution to this would be what we for now call the cycle node network planner, which is basically a tool where you can give all the data that you're trying to get now as an input. And then as output, you would get suggestions on which networks could be planned in that region. So yes, that's the vision. And I'm handing over to Anna. We're already a bit short in time.
Hi everyone. So as Michael has explained, cycling is a marginalized mode of transport, even in so-called cycling countries like Denmark. And it's not only a question of how much space we give to bikes in the urban landscape, it is also a question that comes up in data and data collection. So whether we look at like traffic counts, flow data, routing, or even data on basic infrastructure, we have way less data on anything relating to cycling compared to car traffic. So it's a very clear example of that data reflects the priorities in society, that it's not random what we find worthy of measurement. And also data influences our priorities and decisions. So there are like limits to how well informed our cycling planning can be if the data is not good enough. And as Anastassia just explained, we like to do research that's like relevant to planners and practitioners, and we also work with them. So it's important for us that the data we use is ideally of good quality, and at least that we know what are the uncertainties. So we can't necessarily do anything if the data we're using is not good enough, but at least we're going to know if there are issues in an area. So therefore, we are currently working on this reproducible workflow for assessing the data quality of network data for cycling. It will be published as a series of Jupyter notebooks, hopefully at the end of the year. And it's going to help the user to quantify and also to visualize where we have problems in the data sets. It's both aimed at OSM data or OpenStreetMap, but it can also be used for local data sets from a municipality or a government. Maybe a small note also on OpenStreetMap data quality. So the aim here is not to criticize OpenStreetMap. It is generally of a very good, like high standard. And it's also fairly well researched, but we also know that the quality is mostly when it comes to car networks. And whenever we're talking about infrastructure for pedestrians or for cycling, we have like way more issues and missing data. And these things tend to be mapped at like the last step. So it's important to keep in mind. Before I show any examples of the work, a few words on spatial data quality. So we have these like ISO standards defining it as like completeness, consistency, and accuracy. And we more or less incorporate all of these in our workflow, except of the temporal dimension. But for us, what is actually more interesting is this concept of fitness for purpose or fitness for use. So we might not have perfect data, but what we want to ask ourselves is the data good enough for my use case? So for example, historically, when we look at the spatial data quality, it's often been about the accuracy. So is the features mapped exactly where they actually are in the real world? For us, doing network research is not that important if a bike lane is positioned 10 meters to the left or the right. What we care about is, of course, whether objects have been mapped, and then secondly, about the topology. So are edges in the network directly connected or not? Because this have huge implications for our analysis. Secondly, methods for looking at the spatial data quality, we group them as either intrinsic or extrinsic traditionally. So intrinsic methods, they look at properties of the data itself. So for example, you look at OSM tags, like where are things important to cycling tagged or not? Whereas the extrinsic methods, you take two data sets and you compare, for example, OSM to a local data set and try to quantify the differences. So just take a few examples of what we do. Here we look at the OSM tags that are relevant to cycling. The plot here shows the percentage of edges in like a grid cell that has the surface tag filled out. And it's clear here that like, or at least it seems like the pattern of where this tag exists or not is like, it's not random. So is this one of the issues of crowdsourced data is that data quality is good, but distribution of errors follow this pattern of like where we have many editors. So you cannot just assume like a uniform data quality. Compare the OSM data for Copenhagen and Copenhagen suburbs with the local government data set. And you might say, oh, it's trivial to compare two data sets and see, well, do they contain the same objects? Is the completeness the same? But because of like very varying methods for mapping infrastructure for bikes, it's like actually very complicated to answer whether the two data sets have the same amount of infrastructure in them. What we do here instead is that we try to we match individual features in the data on like the individual level. So what you see, the green lines are bicycle lanes and tracks that exist in both data sets, and the purple ones are those that exist only in OSAM, and the yellow ones are those that exist in the government data only. So clearly OSAM has a much better data completeness, but we also have small areas where the government data would be a more full description. And yeah, then the topology issue, as discussed. So infrastructure for cycling in the real world is often fragmented, has a lot of missing links and discontinuities. So just because your data is also cut into a lot of disconnected components, it's not necessarily a data issue, but we often see that this inconsistency in how to map infrastructure for bikes means that, for example, intersections are sometimes mapped as like being a bike lane crossing intersection, sometimes not. So we have a lot of problems with this like crumbling data in a lot of disconnected components. And as Anastassia discussed, if you use data just for like visualizing, if it's like hand-drawn, this might not be important. But when we do network analysis, it has huge implications for us if things are not properly connected in the data. So just like a quick example of what that means. Here we have plotted for each cell, how many other cells in this area can you reach if you travel on the bicycle network. The first one here is OSM. Then if you compare to like the reference data set, it becomes very clear that because of these like missing data and lack of connectivity in the data, if you use this for analyzing cycling conditions in Copenhagen, you're going to get two very different answers. So it really matters that you look into this. Just like a few concluding remarks, not for us, but just on spatial data quality. When you do cycling research, you cannot assume that your data is of a good quality. I think more often than not, that's not the case. So it's important to check and to like check your assumptions. This can, however, be very hard to do because we don't a thing in cycling research. So it's more a question of like assessing the differences and using your local knowledge to figure out where there are problems. And then also, as discussed, we still have to figure out how to map, how to classify, so it becomes possible to do research across municipal boundaries, across countries, because this is still like an area to be explored. So there's definitely a lot of work to do in the future. Mm-hmm. And then I'll leave the word back to you, Michael.
Yeah, thank you, Ines. So I will be very quick. Now comes the slide where we criticize our own research. So what are the possible problems of just focusing on building bike networks, especially in the urban setting? And we asked this question to like 120 students in a lecture a week ago, and you get a lot of these answers that, yeah, you also need to look into walking, into public transport, and some people cannot bike. And of course, this is all true, and we agree. But what actually I wanted to lead to is that from a network perspective, if we look at this, then this looks very nice. This is Copenhagen's bicycle network. But when you then zoom in on the street level, then it looks like this. So most of the space is still for cars. And we have literally cemented the idea that there is a dedicated space for cyclists, a dedicated, much larger space for cars, and that's it, and a tiny space for pedestrians. And this is also criticized in this book that actually this is not maybe a step forward. This is a step into something like a flow city, where you optimize for flows, but not for livability. So I tried to sit outside a cafe here a week ago with a 4-year-old, and it's just horrible because of all the noise, and if the child jumps 1 meter, then it's already dead. So this is not a nice street to live. So the problem with our approaches so far is that we are only here in the middle, in the not that effective part where we engineer controls. We try to isolate people from the hazard, but maybe we should focus more on the higher levels, on the more effective levels. So this, if there's an image that keeps us awake at night, then it's this one. You have the typical car city on the bottom, for example, Houston. And you can do step-by-step developments to get to a city like Copenhagen. And that's also why US planners love Copenhagen, because they can see you just need to build some bicycle lanes on the side and you get to Copenhagen. But the question is, have we come actually closer to the livable city, or are we getting stuck in some kind of other path? And that's the problem with path dependence. So maybe in Copenhagen, from Copenhagen, it's a bumpy ride to get now to the livable city because everything is fixed. And yeah. It's a very hard question because land use and culture and many things depend on this. Okay, so with that, I think we're done. Just to summarize, we developed tools for planning the best possible cycling networks in some sense. But we are always aware that we always must scrutinize what we're doing, whether this really advances society or if we go back a step, maybe. Yeah, so thank you.
Thank you.
I don't know if you can hear that, but we're all clapping here in Liverpool anyway.
Yeah, we saw it. Thank you.
Great. That was really good. Really interesting, guys. Super relevant work. I can see why Martin and Danny and Francisco approached you to talk to us today. I found it really interesting. So I'm going to proceed with a few questions that that might have popped up. There was a question in the previous thing that has been lost in the ether somewhere. So I think it was it David Sharpington? I think if you had a question, if you're still interested in asking it, drop it down in the chat and we'll come to that in a second. There was a question before we turn to anyone in the room that has questions. There's a question from Raimundo Sanchez about whether you've used Strava Metro for data gathering in this research.
So I was part in a paper, in a preprint that has used Strava to gather data. I'm not sure if it was Strava Metro or it was somehow scraped differently right now. But yeah, I'm part in a preprint that uses that looks at gender differences in cycling. Yeah.
Cool. Great. I'll turn to David, and they've been so patient because they lost their question in the last one. So it's when do you looked at other ways to optimize aside from directness and coverage, i.e. to reduce injuries or equality factors for young people, or actually for livable space, as you said?
I think for now we have not, right? But especially the access for young people or access for specific demographics is one part that is planned, especially in ANS research on the cycling quality of Denmark. Yeah, and we will also study accessibility later for different demographics. So it will come.
Yes, and maybe if we had more time for the criticisms also, I would have added that looking only at the network structure, of course, it's not that meaningful if you ignore who lives where and who has to go where. Yeah. The underlying problem is that it's very hard to get data on that, but it's definitely something that we also want to consider in the future. Yes. Yeah.
It's exciting, and I'm imagining that, like, you guys that are PhD students, is this kind of what your kind of research is going to be about for the next kind of however long, about this kind of issues and these kind of topics. So interesting to see. I'm going to turn to the room. Does anyone here in the Liverpool cohort have any immediate questions? Nothing yet. I'll give them a minute to warm up. There's a question in the chat, but I had a quick question, just generally about OpenStreetMap, really, because I'm not really familiar with like how street network data from OpenStreetMap is really, because I haven't used it. I do a lot of POI kind of stuff, and I was just wondering, kind of in general, because the point of interest data in OpenStreetMap is generally not very accurate. It's very poor coverage, and it's kind of the accuracy and its use in research can be problematic sometimes. Is that very different for street networks? Is it kind of universally accepted in sort of transport geography and this kind of thing that street network data in OpenStreetMap is much better as a kind of general substitute for other products?
Yes, I generally say so, that like we analyze the quality of OpenStreetMap, but I've yet to find a data set that's better. So it's not perfect, but it definitely is, like, especially for cycling and maybe also for pedestrian, I can't say, but it is the best data set. But of course, with these like huge variation depending on where you are.
Okay, that's great. There's a question in the chat from Vincent Thorne about your opinion about Barcelona superblocks. So whether you envision them as a livable street or cars and trucks still need access to these areas and buildings. So how does that come into your vision of livable streets, I suppose, is what Vincent's probably trying to get at.
Yeah, so yeah, we think the super block strategy is a very good strategy. And actually one project that we start in 1 week will be called Super Blockify, where we look into different cities and we want to understand how we could turn those cities into some kind of traffic island or super block structure. So yeah, that sounds like a good solution, definitely.
Yeah, also with this idea that here we do not plan around the car, but rather we start with where do the people live, and then the car has to fit in between that. So it's reverse this approach.
Yeah.
Super interesting. We were only talking about it at lunch because I don't know if you guys saw it. Macron was over here for the Queen's funeral recently, and he made a big joke about the the cycle lanes here in the UK being basically non-existent. So we just thought it was really timely. We saw that today. There's a question from Alex about managing data quality issues when your focus is a national extent. I know you've talked a lot about Copenhagen as a kind of case study, but do you guys do a lot of kind of national extent, and how do you manage kind of quality of data when you're doing that kind of thing?
Yeah, so my PhD will be looking at all of Denmark, so it's definitely is a concern of mine. Like one thing I do is that I combine OSM or enrich OSM data with other data sets, because OSM has this tendency to be of a lower quality in more rural areas. So then we cross-check against like a national data set that is not great for connectivity. I wouldn't never use it for analysis, but it can be used to both like validate and also enrich. So I guess multiple data sources would be a tip. And then we also have some routines in check for fixing data. But it definitely is like very time consuming. So I hope also more research will be done in this area.
Yeah, and I think there's a kind of follow-up question to that, really more about like, I'm sure you'll probably get involved with thinking about kind of the tools and things that might help you to approach that when you're talking about a national extent, because I know a lot of us here in the lab at Liverpool do a lot of these kind of studies where we start small and then end up scaling up, and then you end up needing a whole different approach. So I'm sure that's something you're probably going to have to think about in your research, is it?
Mm-hmm.
Yeah,
for sure.
Yeah, Copenhagen is a different beast to Denmark. Very different.
Yeah.
Cool. Any other questions? Anyone from the room got anything? Any comments or questions they'd like to make? No? Great. Okay. Unless there's any other questions in the chat, I can't see any. I think we'll wrap up there. So, final question in from Caroline. Hi, Caroline. Can I ask, what is the Danish approach to contraflow cycling, where cyclists can legally travel the opposite way to motor vehicles?
Do you know, Anna?
I can answer what the Copenhagen approach is. Also, like, maybe I don't know if this is the case in other countries, but the police in Denmark is doing a lot of like the traffic planning actually. And then depending on which like police division you are under, that influences a lot. But it's in Copenhagen, it is allowed sometimes not. And it seems to be a bit random. Okay. When, but I mean, some of the word from the road directory here says that it is generally like a good idea, and one of the few things that is like just universally good for both like safety and comfort. So
okay, so there are guidelines.
Yes. Okay.
But then, of course, the big question is always, would you let your children cycle there? Yeah. And probably the answer is no.
Yeah, I'd imagine exactly that. There's a couple of hands up. Andrea, do you want to take over?
Yeah, thanks, Patrick. Amazing research. I have two different questions. One is about if you plan to leverage this data to analyze like inequalities at the urban level and like, density or whatever of the cycling networks. The other is, I'm just curious if you consider like electric bikes and how this might change your analysis in general. So thank you.
Well, it's definitely something that I'm very like looking forward to looking more at, this like idea of like transport equity. We've also been inspired by this concept of like forced car ownership, and it's definitely the case in Denmark that often in the more deprived areas are also areas where you're forced to own a car because the cycling infrastructure is too bad. So it's a very important topic to us.
Yeah. And Was there another question?
And so what was your second question?
Electric bikes, if you
Electric bikes.
included somehow in whatever in the computations or general idea behind it.
Not yet. We have colleagues at DTU who are like transport modelers. They make a lot of studies of bikes, e-bikes, and there are more and more e-bikes. Yeah, I just know from anecdotal evidence that the normal bikes and e-bikes, they don't mix so well sometimes on the cycle lanes, especially when the lanes are not wide, because e-bike goes with 25 and normal bike, if it's an old lady or a child, it's like 15, and there are always conflicts. So yeah. In the Netherlands, they have implemented fast bike lanes in some places that I know of, yeah, like for fast cargo bikes. I don't know if that's the best way to separate again, or I don't know. So it's an open question.
Yeah, but it's definitely interesting and something to consider also when looking at like accessibility, because it can really change like the range you have available to you as a cyclist.
Yeah, so this concept of the super cycle highway that we have here, that you build a big cycle highway for 20-30 kilometers, makes more sense if you have electric bikes then. Yeah.
Thanks a lot.
Great. There's a message of praise from Bob in there about point of interest and stuff, and he just said thanks again for your talk. And then Francisco, do you want to take over with a question?
Thanks again to the three of you. So that was very interesting. So Michael, you made a point about why focusing on infrastructure and road networks, and why you haven't considered so far flows of people moving around. I guess I mean, yeah, it's true, right, that people tend to use the existing infrastructure, and what you see may be a reflection of what is already there, so availability of different infrastructure. At the same time, I think is some of that infrastructure is there because it's demand driven. So then the question I had is, so how do you consider to look at, because I think it's an interaction between the two, right? So it's one thing is having the infrastructure there in place, and a different thing is whether people actually use it, and depending on densities, the usage of existing infrastructure may be different. So I was wondering whether you have considered and how you may include and analyze human mobility data into your existing approach.
Yeah, so it's a good point. I completely agree. It's basically a problem of co-evolution with some biases. Yeah, for now, we have not deeply thought about how to combine them. I mean, I was part of a study that looked at flows on one hand and that crashes on one hand, this kind of two data sets to inform bicycle network development in the city of Turin. And you can see then that depending which data set you use, you will have a different short-term network development. But in the long term, if you want to cover the whole city, then these are just temporary differences. Yeah, so I don't have a definitive answer yet. We haven't thought deeply about it yet, but for sure it will also come at some point.
But I think it's a great point, because it also shows how complicated, how complicated everything is, I could say, but how complicated it is to rethink the transport system, because there we can really see how, human mobility, of course, it depends on where can you afford to live and where do you work, and can you afford to live close enough to your job, for example. So it's connected to the housing market, it's connected to the job market, and many other factors which would have to change basically simultaneously in order to, really make a big shift in how people move.
Yeah, but I think there is kind of a paradigm change going on where you want to go from predict and provide to decide and provide. So you want to actively shape the future. You want to build bike lanes so that people come and use it, and not the other way around, that there are car flows and you just assume that they will just increase or stay there. So you want to actively shape your city and make it better. That's the important part.
Yeah, and also maybe like a comment on demand. Like demand is not like a fixed thing. So we have a lot of like infrastructure for bikes in Copenhagen, and there was some demand for it, now there's a lot of demand because biking is the fastest and cheapest and most like, feasible way of getting around. So I think it can also be hard to know whether demand exists or whether you can create it.
Yeah.
So I don't
whether you induce demand, basically. Yeah.
Cool.
Excellent. Thank you.
Okay, well, I don't think there's any more questions. I can't see any, there's no hands up. So I guess just on behalf of the lab here and on behalf of everyone that's sort of attended, I'd just like to thank our speakers for the final time for their fantastic presentation. Just a quick announcement, if you've enjoyed today's brown bag, we have another one coming up in October. We're inviting Kevin Credit from Maynooth University to come over and speak to us about, I would imagine, advanced random forest modeling and its applications to urban systems. So if you're interested, keep an eye on our socials and you'll see more information about that. But until then, just thanks again to Michael, Anastassia, and Anna for their fantastic presentation. Round of applause from the audience in the room.
Thank you very much.
Thank you very much, everyone.
Thank you.
Thanks, everyone. Bye-bye.
Bye-bye.